Every time we invent something, it is emergent. So I found things that shouldn't be on Twitter this morning at all. I mean, at all. That doesn't fit at all. And I said, now let me type it in English, and you won't find anything. Type it in French, bam, you get a lot of tweets. You can use AI as a tool, or you'll be the tool of AI. We have no memory. We create our memory every time we remember something. Like if you're thinking of your house somewhere, it's not in one place in your brain. It's in thousands of places. And then you call it, and it connects, and it brings you your house back. And then when you think of it, it's changed again because you thought of it. So you've added something. So it'll never be the same again. You have Google BERT, which we do not have access to. Because remember, your behavior can be a sequence. You click on this, you click on that, you click on this, you click on that, you click on this, you click on that. So now you're creating a sentence. Go, do, click, leave. And then each time I can measure how long you're spending on it.
Hello and welcome to the Sci-AI podcast. This is episode number 31. Today, my guest is Denis Rothman. Denis is one of the legends of NLP, machine learning, and AI. He is an AI speaker and has authored several books in AI. It is an honor and privilege to have him today on the podcast. Hi Denis, how are you doing?
Well, first of all, thank you for inviting me to express my opinions, and I'm fine.
Okay, great. Thank you, Denis. Let's go ahead and get started then. So my first question is, I've read your blogs and, was very intrigued to ask you, what are MetaHumans and what is the use of MetaHumans in healthcare and education? And if you can, please also talk about Google BERT and OpenAI Codex and GPT-3 in this context.
Okay, so let's start with the word intelligence. Okay, there's not just one form of intelligence. If we take the lowest level intelligence, you have some metals that you go like that, and they're elastic. They'll go back to their initial form, like a rubber band.
Right.
So it's not the intelligence we are thinking of, but it's some form of adapting to something. And then you can go to animal intelligence. We could go through insect intelligence, but then, I won't speak until 4 a.m. So we'll go to animal intelligence. And you can take a crow, for example. People don't like crows because they're big and black and ugly. They remind them of vampires. But a crow can go to a glass, and in the glass, and it wants something that's the bottom. There's some water there, but he can't pick it up. So the crow can go get some rocks, put it in the glass, and make the water go up and eat it. Okay, that's another form of intelligence. And then you have the intelligence closer to us, like chimpanzees. And chimpanzees, if you think about it, since we've been to school, everyone says, humans survived because they adapted and they developed so much intelligence. Okay, why do chimpanzees still exist? They didn't go to school, they didn't go to college. And if we didn't kill them and eat them, there'd be as many chimpanzees as us. So what's happening here? They have a form of intelligence. They just didn't go to school or university. They didn't need to, okay? Our human intelligence was mostly developed to adapt to human society, not to nature. Okay, that's why chimpanzees are there. So now we have a form of intelligence. Okay, then the machines came along. And the machines are not intelligent in the way we think. They don't have reasoning or consciousness or emotions. But it's like a calculator. You can do millions and millions and millions of calculations. So at one point, when you take a GPT-3 model, for example, now you have the GPT model, but you have the GPT engine, and it's not the same thing. The model is the architecture. The engine is the trained model. So now suppose you take 100 billion parameters or 175 billion parameters. You're going to get so many data points and dimensions that statistically you can find out almost anything on anything. That's how it works. So people are saying there's some mystery. There is none. For example, if you say the dog, how many times have you seen in your life dog the? Never. You always see the that comes before dog. So when you have so many parameters with statistics, people say the, and they say, I said dog. Wow, that's a miracle. No, it's statistics. So then you can go after dog. What can a dog do? You're not going to say the dog the. So then after that, after you analyze billions and billions of sentences, you know that the dog is going to do something. Run, eat. There's going to be a verb. There's going to be something. So basically, if you go on and on like that, and you take everything that exists in data sets, at one point when you have all these dimensions, well, it can figure out in a sequence what's going to come next. Now I come quickly to what is MetaHuman. Frustrating for a human to imagine that something can do something better than that human, because we have a lot of pride, and we're so intelligent and we're so smart. But a pocket calculator can calculate much better than us. If you take a scientific calculator and you divide, 859.6 by 259.8, I doubt anyone that's listening to the show can do it easily. You can do it, but it might take you. Just press on a calculator. Does that mean that calculator is more intelligent than I am? No, it doesn't. But there's intelligence in there. It's another form of intelligence. It's just doing things in a different way. Now, the problem we face is that these systems have become so powerful, I'm speaking about Transformers, that they can take 1 trillion parameters and they can take 1 trillion tokens, and it's very disappointing. They can do a lot of tasks better than us. What a disappointment for human beings. Now, how is that possible? Why is it possible? Because of Taylorism. We have spent 300 years breaking human beings into tiny little segment tasks. You are the secretary. You go get the mail. You go get this. So we've broken down what was a nice human being with a lot of open intelligence into very specific tasks. Do this, do that. And it's very limited. It's become so limited that it's pretty easy to replace it. Like someone, give me a summary of a text. Okay. But can I say what I want? No. You give me a summary in 5 lines. Okay, well then you take OpenAI GPT-3, you take the Da Vinci engine. It has worked on billions and billions and billions of summaries. So it'll put a summary together faster and better than us. So now, that's why I call it MetaHuman, because in specific tasks, not in emotion, consciousness, philosophy, religion, no, that's zero. That's not where you earn your money. When you go to your office, no one's asking you about your religion. People are asking you, do this, do that, in very, very small tasks. So that's what I call MetaHuman, because it can do better than a human in many small little tasks. So it doesn't need to replace all our tasks, just the profitable ones. So if you choose the profitable ones, you can use a transformer to replace humans in a lot of tasks. So of course, person saying replace. Yeah, but there's something that people don't realize is that the number of transactions in this world are increasing daily. If you take Facebook, they can't control those billions and billions of posts that come in every day on Instagram and everything. So AI can do it. So we're not replacing it. We're just replacing some kind of intelligence, but we still need all the people. We can't even reduce the number of people because the work is expanding. So no one's going to be replaced in computer science. They're just going to change jobs. And we need this intelligence to go further. So it's the human. You have a system that does better than the human, and a system that extends the human to face all these billions of transactions we can't manage with humans.
That's a great aspect, and I was so intrigued to ask what exactly then MetaHumans mean, and great explanation of it. Some parts of it, like you touched, Denis, which is like not taking away jobs, but it will convert into different jobs. We will come to that with further questions that I have for you. But I mean, because you touched about the Transformers, can I ask you, what are the transformers in a natural language processing? How do they help in parallel processing, and what exactly it helps in building great AI models?
Okay, so let's take something very simple we all learned in math. You say y equals wx plus b. Okay, we all learned something like that even in high school. Or we can even simplify y equals wx. So now you have y, and I say y is 2. No, y is 4, x is 2. So you can say, hey, that's easy. I'm going to multiply x2 by w, that's 2, and I'm going to get y. Okay? But now suppose I give you billions of numbers. Y is just capital Y, and I have billions of numbers on one side, and then the x is billions of numbers, and I have to find a set of rules that makes sure that every time I have an x, I can multiply it by that w I found to get approximately y. Whoa, that's becoming tough. So if I went back to my early example and I say, well, it's 4 and 2 for x. So y is 4, x is 2. You say, yeah, well, I'll multiply by 2. You say, x is 4, and then y is 8. Well, I multiply by 2 again. So you have an algorithm, but it's not the same thing when you're trying to recognize a bird. If you have an image and you're trying to recognize a bird, you have to find a lot of features in it. You can find rules. You can write them down. So I'll write it down. I'll write a little program that says, let's go back to NLP since you were talking about the cat is eating, right? So you can say, I can write a rule. I can say that every time there's I can write that a noun will come out. And every time I have a noun, I'll say a verb will come out. And if I write these rules physically with classical program, I'm pretty sure it'll work. And that's the way we used to do it many years ago. But the problem is, what do I do now when you give me 1 billion tweets or 1 billion posts? How am I going to write all those rules? Because people are not speaking that well. They're making a lot of grammar mistakes. English is spoken in very different variants from country to country. You can write the rules, but those rules might take you 100 centuries to write them. By the time you write them, your language won't exist anymore. So someone had to find another a solution. So that we all began with recurrent neural networks. We say, okay, I have I'm pretty smart. Then I go to dog. Wow. Now I have dog, but I have to remember there was the before. So you pile that up in the memory of your recurrent neural network and say, I have dog, but there's the there, so I'm adding it there. Then when I get to go, I remember go and I remember the dog, and how far can you go like that before you have an overflow in your memory? And why are you limiting it to just the dog? And how are you going to train it with hardware? How can you do any parallel processing with that kind of architecture? So Google came along and say, away with this. Hardware is not going to improve that fast, okay? We need another system. So they decided no more recurrency. You take a sentence, the dog is eating food, and you transform this sentence into a vector, a lot of numbers, and what you do is you take each word and then you split it into little blocks. Let's say the is 512 numbers long. Okay, we're making a vector. Let's divide it by 8. Bing, 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 bing. We get 64. So now I'm working with, I have the that I represent with 64 dimensions. I represent with 64 dimensions. 64, 8 times. I'm representing the 8 times. And I'm representing each word 8 times. And now I'm going to compare them all to each other. the dog. I'm just going to run it randomly. It's just, there's no intelligence. I'm just statistically looking how they all fit together. But there are 8 of them of the same size. So now I can take each one and put it on a different GPU. Why don't you look at the on your side with all the different words? So it'll say the dog sat, it'll find all the combinations, all between themselves. Then the second block will do it in a different way, and you have 8 different ways they're looking at each other, and they're trying to figure out which word fits with which word in which context. Okay, it's like it's like saying dog goes with food, or dog goes with dog food. So at one point, dog will find dog food, and statistically, it will keep finding it again. So it'll create a weight that's stronger, a rule. It will create like an old-time rule. But since you have so many parameters, you have a lot of space to put all these automatically found rules, I would say, weights. So what happens is you can run it in parallel, and it's so powerful because now you're 8 times faster. But that's not all. You can have a lot of layers. And you can run all those layers at the same time. You can run all the layers on other GPUs. And then you can say, why don't I just split the memory? And so you can split it up in so many ways that now you have trillion parameter models that you can train like 11 billion parameter models because they're so smart and well organized. So I would say, of course, I can't sum it up, in a few minutes in a podcast. That's why I wrote a book, Transformers for NLP, 2nd edition. Okay, so it is now 2 things come from there. You have two very important things. One is emergence. No one knows what it's learning. Because of all these combinatory things here on billions of, no one knows what's going to come out of it. So in fact, one transformer like GPT-3 trained to be an engine like Da Vinci can do hundreds and hundreds of hundreds and hundreds of tasks. How does it do it? You just start like, I would like to eat, and then you just let it finish the sentence. But since it's studied so many billions of sentences, you can say, please tell me, suggest something I can eat. I would like to eat. And it'll just continue the sequences because it has in memory all of the sequences it's found on the internet and all these sentences. Like you're going to say, Denis, OpenAI, please ask a question to Denis based on what we just said. All it will do is take everything we said before, go look in its memory of learning and find something similar and just spit it out. So that's emergence. It's so powerful. I mean, that's why I honestly say you have to read the book to understand it. It's so powerful. And then the other thing, it's homogenization. Because once I have the sequence for words, I can use it for an image. You can take an image and convert it into a sequence as if it were a sentence. Now you can predict images. You can even create new images. You can do it with music, with behaviors on YouTube. What do you think they're doing? Google search.
So what I learned from this is that maybe it's more or less like pattern recognition. Like you said, these are when they're divided into different vectors and they are doing these parallel processing. Aren't they actually doing some sort of a pattern recognition and then making models out of it?
Yeah, of course. Everyone's afraid to say it, but basically no one can escape patterns. And there's a pattern in everything. Like when I was describing the crow has a pattern. When I said the statistics are patterns, we find statistics predict something, but it's a pattern because you say something and you get to something else. So, of course, it's in the umbrella family of patterns. I mean, everything is a pattern. Even a chess player cannot work without patterns. Yeah, of course, you can say it. Why not? It's like a form of patterns. Of course, it doesn't know the system is not aware that it learned patterns.
Right. So my next question is that we stay on the topic of Transformers, and then can we also discuss about the most powerful Transformers of all yet, or at least how I think it is? You touched a little bit on GPT-3. What do you think are the practical applications of GPT-3 other than just writing articles and self articles by itself?
There are two parts, there are two important concepts that you just brought up. One is, what is a powerful transformer?
Yeah.
Okay, Stanford University calls the powerful ones foundation models, because these foundation models are so unpredictable. They can do anything once you just prompt them. You just start as something and they'll continue it. And that you can make recipes. I have these ingredients, tell me a recipe. So that's the emergence part, homogenization. And you need a certain number of parameters. You need 100. There's no such thing as a model under 150 or 200 billion parameters now. It's too small. If you want to represent everything, it's like I say, how many people do you know? I know 100 people. Okay, so I'm going to give you a piece of paper, and I want you to put little data points and show the ones that are closer to you and the ones that are further. So your family is close, then you have your friends, then you have the co-workers. So you have this little piece of paper, let's say 10 times 10. That's 100 parameters. Okay, now I'm going to give you 1 billion people. Put it on that little piece of paper with 10 times 10. So now, this is I must say candidly, some of the stupidity I hear is, I can do a lot with my small model. Well, sure, take a piece of paper and put 1 billion data points. So if you don't have this huge representation, you won't fit them in the vectors, because they'll keep overlapping and you'll keep getting mistakes, errors, inaccuracies. You need that space to put them in that space. Okay? And then the second thing is, people say, Dennis, human beings only have 80 to 100 billion neurons. So a trillion parameter model. But is someone thinking of how many connections? The connections between our neurons? Like, even when you're saying microphone, you're activating maybe 15,000 neurons. So we have a lot of neurons, but we connect them. And when you take all those connections, those are the parameters. You know that we have no memory. We create our memory every time we remember something. There's, like, if you're thinking of your house somewhere, it's not in one place in your brain. It's in thousands of places. And then you call it, and it connects, and it brings you your house back. And then when you think of it, it's changed again because you thought of it. So you've added something. So it'll never be the same again. And then that's why when we're a child, we see the house as something big, and then we go back, we see it smaller or older. Yeah, so you have maybe neurons, but we have trillions of connections of these neurons in our mind, and these models are still extremely small with 1 trillion parameters. They would need trillions of parameters, which they will have one day. So that's a foundation model. So anyone that tells you, I have this 10 by 10 module, 10 million parameters, well, sure, I'll give you a piece of paper and you show me. So now it has to be large, and it has to be smart. You don't activate all the neurons at the same time. So the latest transformer models will only activate part of it. So it'll go very quickly. So that's one thing. So the only ones that qualify are OpenAI GPT-3. You have OpenAI that developed another program that's called CLIP, another model, CLIP for images, which is very, very powerful. And then let's go back to Google, because after all, Google invented all this. You have Google BERT, which we do not have access to. Everyone thinks you can go to this website and get it. No, they're not sharing it. The real version they have is a huge version they're using for Google search, mainly on Google search, and probably little by little on YouTube and all the other channels. Because remember, your behavior can be a sequence. You click on this, you click on that, you click on this, you click on that, you click on this, you click on that. So now you're creating a sentence. Go, do, click, leave. And then each time I can measure how long you're spending on it. How long are you spending on your video? So you can use classical AI, classical software, add transformers, and okay, since he did this in that order, now he's going to do that. So these algorithms, so they are there. These are called recommenders. These recommenders are the ones that recommend the books, the advertisements, the next video you're going to watch, the next on your search engines. It's all over the place. But these transformers are in pipelines. They're in pipelines with classical software because you need the data. Then classical AI, then classical mathematics. Then the transfer can come in as a turbo, and it's basically used as recommenders right now. What's fantastic is it's invisible because no one knows what artificial intelligence is anymore because they don't know transformers have replaced almost everything. No one knows how this works, and no one sees it because YouTube doesn't advertise, we're giving you this next video. You know why we're giving it to you? Because we did all these calculations on your behavior. Now, there's one little feature that Google is adding that is true, is with advertisements. They are trying to create an interaction with us on the advertisements. They're trying to improve the advertisements we watch. So the next time you go somewhere and you might see Google advertisements and there's a little cross where you can shut it down, but there's also a little place where you can open a screen and it will tell you why it shows this advertisement. And it will ask you if you want to improve it. And there's also features in Google Chrome where you can choose your ads and change them and all that. They're trying to customize, they're trying to do their best so that we get the advertisements we want. And I work a lot on that when I'm on YouTube. Since I know the algorithms, I work a lot on choosing the advertisements. And honestly, now I get really the advertisements I want to see, very interesting advertisements and very interesting videos.
Yeah, sorry. I was saying, is it the same when you click on it and then it says, what kind of ads do you want to see? So you're helping Google or the browser to sort of understand.
Yes, because there's what we call content filters. OpenAI, for example, has an engine, a GPT-3 engine called Content Filter. With Content Filter, you can filter anything you want. Bad ideology, bad meaning what you don't like, because the person on the other side thinks it's good ideology. So it just depends on which side you're on.
Which side?
Someone's on one side, the other side. It just depends who's writing the content filter. Okay, so you have the content filter that can be used for things like that, but you can also use it to the benefit of a user, of someone that's there and saying, no, he doesn't like that, so let's filter it. Now, if you don't, do you watch Netflix?
Yeah.
Netflix has one of the most powerful recommenders in it. It's one of the most powerful recommenders. I know exactly how it works because it started out with a Boltzmann algorithm that I know very well, and I have spent a lot of time selecting what I like and what I don't like. Even movies that I haven't watched, I'll go and like them. It is also based on the duration, so you can't trick it like that. But not many people know that. You can go to the profile, and you can exclude movies you don't want to see. Now, it's used normally for parent control, but if you take movies that you don't like that keep appearing, and you go in there in that profile and you say, bam, I don't want them, it will activate a content filter, which is a very intelligent system, which will find all the features in every movie. It will look for the features of the movie you didn't like, and once it finds those features, it won't show you those movies anymore, or the streaming videos anymore. So what I'm saying is someone that understands it can get a lot out of the internet as a user. If you understand what I wrote, you understand what I'm saying, then you begin to see how to use everything as a tool to your benefit, because basically I waste very little time looking for movies or anything, or music. I do the same thing on Spotify. I do the same thing on YouTube, Amazon. So basically, I've optimized my time. Where people search, I don't search. I get what I want right now. So maybe I save hours and hours per week. And that's years in a lifetime.
Right. That's a great point. But then does it mean, when you say if you know how to use it, then does it mean that because everybody is not tech savvy, everybody doesn't understand Transformers, everybody doesn't understand content filter and how pipelines and recommenders work, then does it mean that, we just, whoever doesn't know that, then we're just dependent on the algorithm, how it's seeing my kind of suggestions or my kind of likings, and then I would have to follow it?
That's a very difficult question here, because it's taking me out of my comfort zone, because it goes back to your first question. MetaHuman. These systems are smarter than us. That's it. They're smarter than us. The recommenders that are in Google search, YouTube, Spotify, news streams are smarter than humans. Much smarter. Because they know much more about human beings, because they're learning everything. Everything you're doing is going into these algorithms. Everything. Like you say, I don't have an account on Facebook. I love people that say that. I don't have an account on Facebook. I said, you don't? Yes, you do. No. But you have a profile. No. I said, yes, you do. Because every time you go to a website and you have cookies, accept, don't accept, don't accept, sometimes you're just tired and you accept them, right? Now, what I do, since I'm not like everybody, I regularly take every single partner, they say, take them out, put them in an Excel sheet, and investigate who these companies are, one by one, 100, 150, 200, all of them. And all of them go back. Some go out, but in this list, many go all the way back to YouTube, to Facebook, to Google, to all the Microsoft, because they're pumping data off every single website in the world where they're partners, okay? And they build this, they get these data sets, and with these data sets, they can train super AI algorithms that know our behavior better than we do. Because we don't remember what we do. We're just watching and clicking and everything, and we're not, but they're not. They're mathematical. They're remembering like a robot remembers. So now you're going back to MetaHuman. We're facing MetaHuman recommenders that are smarter than we are. And what they do is they will show you something you want to see, but then it'll show you something just next to what you want to see, but where it wants to take you. So it's not exactly that movie, it's just the movie next to it.
Right. That is so deep. That is something like changing your viewing behavior, deciding for you what you should see.
Yes, exactly.
Right,
now,
right.
It can only happen, that's where your question is very difficult, because it can only happen to someone that is not an expert in Transformers. In Transformers and recommendation systems, well, in fact, I like it. I like to see what they're doing, because then I can reverse engineer them. You can use AI as a tool, or you'll be the tool of AI. There's no in between.
Right.
Either someone really understands how AI works and uses it as a tool, or this person will be the tool. So now you have this system that is a metahuman that is smarter than us and can recommend things. And on top of that, there's content filters where they filter where they want us to go, like certain ideologies, certain political parties. We know that in the United States there's a conflictual ideology between half of the population and the other half. So we don't know where BigTech decides. Most of the time it's pretty good. Okay, I have to.
Right.
But I have done very deep experiments. I have done very, very deep experiments where I take a list of research questions, Google search questions, and I see where they take me. So I write it down because I'm trying to figure out where it's taking me. And sometimes you'll say it doesn't take me exactly where I want. It's taking me somewhere else. And I won't give examples here because it will become political or something like that. But you can imagine that certain countries in the world, there's a bad image of them that is given, and they're not necessarily that bad. So I'm not speaking about the present conflict. I'm speaking about in general of the 200 countries. You can get a lot of cliches, you can get a lot of things, but you can't reach the country. You can't reach the person. And you can't reach it because there's a filter, and I would say it's not even done on purpose. It's a cultural bias of a whole civilization, because for this civilization, since that's not good, well, it'll be not good. I mean, the whole civilization thinks that. So that's that. You have the meta-human that's smarter than us. So as long as it's for business, I don't mind, because it's pretty obvious, you know. You write an email where you're going on a trip, then you get advertisements. Now, that's cool. As long as you understand it, it's okay for everyone. But when you don't understand that, and then you're just a victim of it.
How is it possible then for the Facebook? Let's take an example of Facebook. So how is it possible for the developers at Facebook to sit and decide what I should see next? Because that's humanly not possible.
That's a
right?
That's a fantastic question. So let's go to the top. You have Mark Zuckerberg. So he's called to Congress, and I've watched these congressional things. Mark Zuckerberg, why did Facebook say that for that post? Okay.
Right.
So you're talking to a billionaire who likes to surf a lot. He likes to go on yachts and all that. He doesn't even know what's in that system anymore. You know, he's a billionaire. You think if you were a billionaire, you'd be worrying about what's happening in you just go there and you do these videos on Meta and how good, and then you go out and have fun. I mean, you're a billionaire. You get in your private jet and go somewhere to an island where you don't see any of us, and you're quiet, and you can have a nice time on the beach. So now we're accusing him of something that he doesn't even know about. So now you go to the next level. Okay, now you get to, I don't know, I won't give names, I know the names. So you go to the next person and you say, well, you're a genius. What do you know about why did that post not make it, and it was like almost banned or something? They say, I don't know, because I think we have maybe, 100 algorithms. But I thought you had Transformers. Oh, we have Transformers. We also have cosine similarity things. We also have content filters. We also have... And the guy comes up to the list and says, I can't really remember. Maybe we should go down. Let's go see this person over there. So then you go see this person. Now you're level 3 or 4. The person says, yeah, I know exactly what's going on with cosine similarity. So you have cosine in a trigger right on your circle, and there's a line, and then you find something that's close to the other. But the guy above says, is that all? Oh, no. There are 50 other algorithms. Oh, can you explain? No, that's another department. Where's that department? Oh, it's over there. So you go to the other department and says, and he has another algorithm. What about, oh, no, we bought that from another company. The guys are not here, but we can call them. Let's do a remote. You call the remote. The guy says, the guy's on vacation. But let's call him on vacation. The guy says, I don't remember what I developed. That was 5 years ago. What are you talking about? So what I'm saying is they don't know what's inside. They built something huge, And then what they do is they do it manually. You have this person there, and then it goes back to 1980 NLP, where you're looking for keywords.
Right.
So if someone says a keyword that's sensitive, ping, it'll go into a list. Then they have some classical NLP stuff saying, are there more keywords? And then it'll probably go to someone who says, are we going to ban this? Or are we not going to ban that? Or am I going to ban it? Who am I going to ask? So Zuckerberg's on vacation. Why don't I ban it? And then someone is banned, and then someone said, the post is banned, says, why did they do that? But there is no real reason. It's just what's going on in the media. This guy's good, this guy's bad, and say, well, it's probably bad. And that's how you ended up with this problem in the Netherlands with, I think it was the Rijksview Museum. I don't know if it was the Rijksmuseum or another one, where all the paintings of nudes were banned on Facebook because they were nude. So you had a nude of an 18th century painting, and it was banned. So what this museum, I can't remember, I think it was Rijksmuseum, what they did one day is in that museum, they put little, they covered all the nudes on the paintings, and we say we can't show you them because this is not good content on Facebook. So the people were saying, what's going, just to make fun of it. The data is huge. The number of posts coming in is huge. The way people write is totally random sometimes. Me, see you, see me, see, go. How can you even interpret that? And then you have these poor people, this poor Zuckerberg just created this small company not so long ago, and it became so huge. And he's in his private jet somewhere, and he says, gee, why do these people hate me so much? What did I do? I didn't think it was going to be that big, and I'm trying to do, the president just called me. What did he say? Oh yeah, filter that. His opponent called me. Well, then filter that too. What am I going to do? It's very difficult. People don't realize that if we were in that situation, it's extremely complex. So we have these recommenders that are recommending things that are smarter than you, but not everybody really knows what's going on in there. So you have this wild algorithms all over. It's a chaotic world. But when it comes down to really filtering, it's 1980 software where you just filter the words and filter the articles and the people. Might be an 18-year-old intern, doing that.
But I mean, I'm really scared now because of the fact that, because of the fact that if somebody is controlling so much of data, doesn't know what's going on in the middle, and they are recommending something to somebody who is then forming an ideology based on that, on those videos, based on those posts that they see. I mean, this is really, really scary stuff to me.
The word, there's just one word you have to take out, is control. Because there is no control. This is mathematics. Like you go to YouTube. Okay, let's take a very precise example. You go to YouTube.
Sure.
And you click on a video. Okay? So you watch that video. It will take all the features in that video. Let's say it's an action movie. Okay? You have the action, did this, all the types in it. And then it will go look for something similar. There's no intelligence. It'll just go look for something similar and suggest it. So then you click on it, it'll give you more. You click on it, it'll give you more. It'll just give you something. But at some point, either because it wants to get you to an advertisement, or either because it's just random, it will show you something that's not exactly what you want, but you're curious enough to click on it. So if it was random, it will go nowhere. But if it was for an advertisement, maybe they'll get some money out of it. And then all of a sudden you click on something that is not good. Not good in the perspective of Western civilization or big tech, for example. And then someone's going to complain in the comments. What is this video? What is this going on? Why do you allow this on YouTube? Oh, this is detected with keywords, and now it comes back to your 20-year-old intern. Yeah, what am I supposed to do with this video? But people are complaining. Yeah, but there's freedom of speech. Yeah, but it's something of this political party. It's not good. Well, let me call Washington. Washington, what do you think, senators? Are you going to call me in a Senate meeting if we allow this? It's not good. So then the video is going to be taken out because influent people are criticizing it. Not because maybe big tech has no ideology. They just don't want problems. They want legal suits. They don't want to be prosecuted or stuff like that. So they just take it out. Then people complain. You took me out. You took me out. And then they'll take all the videos that are like that out, or they'll be more subtle, like in Google search. They might not take it out, but sometimes you see 1 million results when you ask for something. Well, it'll be result 500,000. So you can find it. We didn't censor anything. If you click on 2,000 pages, you'll find it, what you were looking for. So I would say you take the word control out. It's just a mathematical algorithm, and from time to time when someone complains, there's a filter. But it's not something where they just don't want problems. So they'll just take it out. Take that out so I can go back swimming or taking my jet. Just take it out of there. And then someone will complain about free speech, so they don't know what to do anymore. In fact, these are very poor people. I don't envy them, and I envy them for their how rich they are. But I don't envy them to be managing something like this because it's out of control. Like I've noticed something very interesting. I found very funny.
Yes.
You can probably have this too, because you speak several languages. You speak English and maybe Hindi or maybe another 2 or 3 languages.
Swedish.
Okay.
Yeah.
Swedish, by the way. Okay, so what happens is these algorithms are extremely good in English. They're extremely good. I mean, they're really metahuman. And and all the people working there are fantastic because they're all English speakers. Now I've noticed that things are banned. I mean, really banned. You can't find them on Twitter, or they won't find it. If you type a certain type, you won't find it. But I found that if I typed it in French, I found everything that was forbidden in English. So now I know what they banned. I found it in English. You could probably find it in Hindi. So you could, not in Swedish, because Swedish is very close to German and English, so it's pretty easy to understand. Right. But things that are banned in one language are not banned in another because they don't understand it. So I found things that shouldn't be on Twitter this morning at all. I mean, at all. That doesn't fit at all. And I said, now let me type it in English. You won't find anything. Type it in French, bam, you get a lot of tweets. So that's how you find how it works. You can reverse engineer these systems. You can reverse engineer them completely once you understand Transformers. You can even play like a profile, you change things and you see what it suggests. Oh, that's how it works. Okay, now let's do it. I'm going to do it to my profit now. You can learn how it works, and then you can use it to your benefit to get the information you need.
So basically, the writers of these algorithms actually took bilinguals and interpreters for granted, because otherwise they would have created algorithms in which, like you said, the language would be consistent. I mean, their rules would be consistent towards all languages.
It's too difficult. There are many languages, and there are many ways of expressing things in each language where you can suggest something without saying it. So it's extremely difficult to do that. But what I'm saying is, these are not bad people. They just have this huge system. And remember, I was telling you, Transformers are based on emergence. That means we don't know what they're going to say, and we don't know what they're going to do unless you really write a good prompt. So you can end up with I do a lot of Google search. I do a lot of reverse engineering using these systems because I do it like I do video games. But it's just that they're so powerful, they can think in any way. But then that means they're not controllable because no one can think like that. We're going back to MetaHumans. No one can, I can't do the hundreds of tasks it's doing. Like you were speaking about codecs early in the interview, you can convert natural language into source code. I can't do that with every language that exists. So it's, on one hand, it's emergence. It can do hundreds of tasks it wasn't trained for. On the other hand, no human being can do that, so no one can control it. Right. And that's why it seems so brutal to people. I was banned, but they don't understand. But if they weren't banned, there's not enough intelligence in the algorithms to find out which tweet would be good or not for them. It's too complicated. If someone writes a bad tweet, how do you know if the next tweet is good or not if your algorithm is not powerful to detect it automatically? So you can't hire one person per human being. So once you find someone that says two or three things that bad, you just take them out, because maybe the next time they'll be fantastic, but your algorithms can't detect that much. Reaching the limit. Now this is not. This is a very classical thing that there's a thinker in France called Claude Lévi-Strauss, which was an anthropologue and all that. He's very famous. And he gave us a rule. Humans always invent technologies that they don't master, by definition. And then it takes them a very long time. Imagine the first person that found a fire. He discovered a fire, and then how could he imagine everything it can do? You know, he had this thing in his hand, maybe with lightning or something, and he says, oh, it's light. Then he goes into his cave and say, wow, I can see all the time. I can see all night. Oh, but I can cook food. Hey, you know what? I can burn somebody. I don't like that person, so I can burn them. So, hey, I could use it as a weapon to burn someone's whole place. And little by little, humans over thousands of years discovered all the uses of fire, all the way to creating new metals. So what I'm saying is, when we find something, it's necessarily emergent. We don't know what we're going to do with that. Like, think of a knife. The first knife was maybe just, to cut some wood or to cut some meat. But then one says, maybe I can kill him with it. So it became a weapon. But how can you... So what I'm saying is, every time we invent something, it is emergent. But we don't know until... So when Facebook was created, how could he imagine all of that? He couldn't. That's why we can't incriminate him totally, because we wouldn't like Facebook to stop. But we don't like Facebook to continue. So stop, continue, human beings.
Right. Okay, that's fantastic, Denis. In this episode, I've exhausted my questions. It was a phenomenal time I had. You've blown my mind with some of the concepts that you've shared. But whenever next time your schedule permits, we will do a round 2 soon.
Well, I had a great time because you asked some pretty deep questions. You took me out of my comfort zone, which is exactly what I like. I like to live through in the podcast. So I had a great time. And
Sure.
Thank you for your deep questions.
Thank you, Denis.
Okay.
We'll talk to you soon
Bye-bye.
then. Bye-bye. Take care.
Thank you for listening to this podcast. Please support this podcast by liking, commenting, sharing it with your friends, and also subscribing to this channel. Thank you, and we'll see you next time.